In this video, I want to discuss the components of writing R scripts. Let's look at the preparation, the parts of the script, and the process of writing a script. As we talk about scripts, it would be helpful to have a side-by-side example. So that's exactly what I'm going to do. Here's the example. Write a script that will facilitate the analysis of comparing quantitative scores for two conditions. Consider the possibility that some scores may be missing. Include a graphical display, descriptive statistics, and inference to a larger population. Make sure to check the conditions necessary for valid inference. This is the script that I have created that actually addresses all of those requirements that I just listed. We're going to go through this and look at different parts of this, not for the code, but for how I set up the script. Now, it's worth taking a few moments to talk about scripts versus notebooks. As you know, notebooks allow you to combine R Markdown with scripting, where the script is in a code chunk. So everything that I've done here, I could do in an R notebook, and I could include all the code in code chunks in that notebook. But I want you to know how to write scripts within scripts as well as within code chunks in notebooks. Why is that? In a few weeks, we're going to be learning how to create our own functions. When we do that, we're going to need those in scripts, not in notebooks. What the functions will do, as you know, is you will name the function, you will call the function, and the function will do something for you or return a value. So when you write your own functions, you'll be doing that within a script, and then in the notebook, when you get to the code chunk, you can call that function that you've written in a script. What does that do for your notebook? It keeps the code chunk nice and clean. If every single code chunk had all the code without calling any functions other than, say, operators, because we have to call some functions to do something, if that was the case, all of our notebooks would be huge. Think if all the built-in functions that we use, built into base R, think about if we were actually just using the underlying code rather than those functions. And think about having to call 10, 20, or 100 of those built-in functions. Our notebooks would be huge. So part of the process of learning how to create good notebooks is learning how to minimize what we put in our code chunks. I think of it this way. The notebook is to create something for an other reader, someone besides myself, someone external to the processes that I go through when I script. So when I create a notebook, I'm thinking about the final output. You know what you get when you actually hit the preview button? Or when you look at your notebook output in a web browser? That's all done with the audience in mind. So we think of the code chunks not for the audience, but for ourselves. If we can make those code chunks more readable, smaller, more efficient, we can focus more of our attention in the notebook on actually writing for the audience and then having small code chunks that might perform rather large tasks because they're calling on functions that we've created. So that's why I'm putting some emphasis here on learning how to write a script in a script file. The exception to this is when I am teaching. When I'm teaching you how to code, I might create notebooks in which my text is referring to the code chunk. But that's normally not what we do when we do notebooks, right? Normally when we do notebooks, it's to create some pretty output that analyzes data, that makes a presentation of that. So the emphasis is on presenting. My emphasis in our notebooks in my statistics courses and in this R course is for teaching and teaching the statistics or teaching the coding. So that's the one exception where a notebook may actually be for the purpose of having both nice readable R Markdown text and code chunks where the students can see exactly what it is that I'm doing. So I'm wanting you to think about your work moving forward, not about me as an instructor, what I do. So when you look at my notebooks, I'm hoping that will help you understand why maybe sometimes I seem to violate my own rules that I'm giving you. It's because my purpose is different than yours. Yours is going to be to analyze and present data. Mine is teaching you how to do that. Okay, so with that difference in mind and that little preamble, this is the script that we're going to use as I work through this presentation. I'm going to point out to you the various parts of this script. Let's talk about the what and why of scripts. An R script is a collection of comments and code to accomplish a specific purpose. It is written in a plain text file. When you write in a .r file that is an R script within RStudio, like this one, this is actually creating a plain text file. All the .r files and all the .rmd files are plain text. I could use a text editor and open those. So you could try it. You could use your favorite text editor. Mine is Notepad++. And I could open up the R code with that and I can read it. That also makes it valuable when we are using Git processes and GitHub, because as much as we can stick with plain text in those processes, the better. In fact, as you know, I ignore all files like, for instance, Excel files that are not in plain text when I'm using Git and GitHub. The R script includes inputs and outputs. Inputs can include keyboard entry. That would be if we want purposefully to have the user of our script enter in data directly from the keyboard. Or inputs could be data files, or it could be nothing. That is, you can write scripts that do something without any variation in what's put into the script. We don't put anything in, and it does something. Outputs can include graphs, statistics, or perhaps files that we create as part of the script. Our scripts can be reused. If you type in the console, that's fine if you're going to treat it as a big calculator. But otherwise, there's limited reuse value. There are ways in the console of calling up your previous commands, but that has limited value compared to a script. So I do just about everything in a script. Even when I want to put in 4 or 5 commands, I know that I'm going to make typos along the way, and so I put it in a little script so that I can reuse the script and make modifications when I find an error. Our scripts can be created and refined over time. Another reason to have an R script is that you can think of it as an evolving process. R scripts support the reproduction of analysis. If I were to type in the console, I might type it different the second time, but if I run the same script over and over, it's doing the same thing every time. Now let's talk about preparing to script. First, we should clearly define what is the purpose of that script. If we look at this class example, what is the purpose here? It's to analyze quantitative scores for two conditions and compare those. That's the purpose. So we can already determine what the inputs are from this. We're going to be inputting data, and the data is going to need to have a variable that distinguishes between at least two groups, as well as the quantitative variable that we're going to compare for those groups. So understanding the purpose of the script will help determine the inputs as well as the outputs. That is specified here include a graphical display, descriptive statistics, and inference to a larger population. Now we can be more specific about these outputs, drawing on our statistical knowledge. We know the graphical display probably is going to be side-by-side box plots, so that's more specific. The descriptive statistics can be the 5-number summaries, the means and standard deviations for the two groups that we're comparing. And then the inference could be a confidence interval for the difference in means. Note that we also want to make sure to check the conditions necessary for valid inference, which tells me that I will probably have another graphical output, namely a QQ plot, in addition to my graph that is the side-by-side box plots. Once we've determined the inputs and outputs, then we should think about the available resources we have and what we're going to need. We always have in RStudio the little help tab. We also could use the question mark operator. We could do web searches. Cheat sheets can help. So we have to think in terms of the problem we're trying to solve, and do we know what functions we have available to us to help solve the problem? Now, it may be a function exists that you don't know is out there, in which case you end up writing your own code when you didn't have to. But that is something that you'll learn over time, what functions are available to you, so that you know when you have to write your own code and when you don't. I'll give you this little clue. If this is a task that others have probably needed to do, there's probably a function out there, and doing a web search might be very worthwhile. So, for instance, let's suppose now that I'm going to create a QQ plot. If I do a web search on QQ plot with R in the web search, it's probably going to return something so that I don't actually have to create that graphical display.